Good morning students. Today we will discuss about the phenomena or process of refraction. In the previous chapter we have already discussed about the reflection. That means at that time we are considering about one medium. So we know when light travels in one medium then it propagates in a straight line. But what happens if it changes its speed of light, or you can say if we change the medium, that means if light travels from one medium to another medium, then what will happen? Generally we are considering three types of medium as discussed earlier: air, water and glass. So for example, suppose this is a glass slab. If a ray of light is incident on a glass slab, PQ is the incident ray of light, and at the point Q it strikes on the glass slab. That means this medium is your glass medium and this medium is your air medium, or suppose this is your first medium and glass is your second medium. Then after striking at the point Q, it bends, but this bending of light will take place in two ways. One is here towards the normal and second way is here away from the normal. Away from the normal. So now we will discuss about when the ray of light bends towards the normal or away from the normal. Before that, the speed of light is maximum at air medium. That means, in other words, the air medium is also called as your rarer medium. And the medium in which the speed of light is less as compared to your air, that medium is called as your denser medium. So according to this diagram, we can say the first medium is your air, which is your rarer medium. Why? Because the speed of light is maximum in air, which is your 3 into 10 is to power 8 meter per second. And the second medium, that is your glass medium, which is also called as your denser medium. Clear? Now, when the ray of light travels from air medium to glass medium, that means in the first medium the speed of light is maximum, and after striking at the point Q, the speed of light will be less. That means the bending of ray of light or the refracted ray will bend towards the normal. Towards the normal means if you draw the normal and PQ is the incident ray, so this angle is your angle of incidence. Similarly, this is your normal and this is the refracted ray. Suppose QR is the refracted ray, then this angle will be a R. So, when light travels from rarer medium to denser medium, its speed will decrease, or in other words you can say the refracted ray will bend towards the normal, or you can say the angle I will be greater than your angle R. Now we are considering second situation. Suppose our incident ray is in a glass medium. This is your incident ray PQ and this is glass medium. If you draw the normal, then normal you can find out the angle of incidence. Now, when the incident ray PQ enters in the glass medium, after striking at the point Q, it will bend in the air medium. So, glass is our first medium and air is our second medium. Now, in glass medium means in your first medium, the speed of light is less, and in air medium the speed of light is your maximum. So, obviously the ray of light bends away from the normal. Clear? Now, compare two cases. Here the incident ray of light is in your air medium, means speed of light is maximum. And in second case, the incident ray of light is in your glass medium, means the speed of light is less in your glass medium. So, in your first case, the refracted ray bends towards the normal, and in second case, it is clearly observed that angle I is less than your angle R. So, we can remember like this. These are the important points. First point is if angle I is greater than R, or you can write down that the speed of light is greater in first medium as compared to second medium, then it bends towards the normal. And second point is if I is less than R, or you can say R will be greater than I at the time, then the refracted ray, it means the refracted ray bends away from the normal. Clear? While drawing the diagrams for your refraction, you have to follow these 2 points. If you are considering the first medium is your air medium, suppose this is your first medium, air medium, means this is your incident ray, this is normal, and the refracted ray will bend towards the normal because the I means angle of incidence is greater than your this is your refracted ray, so this is your angle of refraction. So it is clearly observed that angle I is greater than angle R. That means if RS is the refracted ray, then it will bend towards the normal. If you we will draw the refracted ray like this, means away from the normal, then your diagram will be wrong. So, while showing the process of refraction in your diagrams, give the importance to the mediums so that you can easily find out whether the angle of incidence will be greater or the angle of refraction will be greater. Then you can draw the refracted ray according to these 2 points. This is the process of refraction. That means from all the observations we can say the bending of light, when light travels from one medium to another medium, the process is called as your refraction. In your reflection, that means in your previous chapter we are considering only one medium. So the process of refraction will occur when light travels from one medium to another mediums. Now we will discuss about the laws of refraction. Laws of refraction. First law, according to the diagrams, PQ is the incident ray and QR is the refracted ray. So according to first law, the incident ray, the normal and the refracted ray means all the three rays. All three rays means incident ray, normal and refracted ray all lie in the same plane. Clear? Plane means maybe your blackboard, maybe your drawing sheets, etc. Already we have discussed in your previous chapter, reflection. Now, second law, which is your most important law, and second law is also called as your Snell's law. So, according to Snell's law, the ratio between your sine of angle of incidence and sine of angle of refraction is a constant. That means sine I divided by sine R is equal to a constant. But according to the laws of reflection, only angle I is equal to angle R, and at the time angle R means angle of reflection. But according to the second law of refraction, which is also called as your Snell's law, the ratio between your sine of angle of incidence and sine of angle of refraction is a constant, and this constant is also called as your refractive index. This is a new term, so you have to remember this. Now, what is a refractive index? Means you can define the refractive index in the form of your Snell's law also, because according to Snell's law, sine I by sine R is a constant. Now, what is the value of your sine I or sine R? You may consider for any other angle. Suppose angle I is your 30 degree and angle R is your 20 degree. Then sine 30 means a numerical value, and sine 10, that is also a numerical value. So if you find out the whole value of sine I divided by sine R, that will be equal to a numerical value. So that is called a constant, or that is called as your refractive index. That means while we are discussing about the refractive index, the incident ray of light must be in your first medium and the refracted ray will be in your second medium. After refraction, we will consider or we will discuss about the refractive index. So, refractive index can be written by the symbol N. But sometimes we can write down N21 or N21 or N21 like this. Now 21 means what? Suppose I am writing in the form of your N21. You can read as your N means refractive index of second medium with respect to first medium. 21 means second medium with respect to first medium. With respect to means relative to first medium. You have to consider the refractive index or the process of refraction in second medium with respect to first medium, because after the incident ray of light strikes at the interface of the two mediums, then the refraction will occur or the refractive index will take place. So now it is clear. You can read as your N21 means refractive index of second medium with respect to first medium. If you can write down here N12, that means refractive index of first medium with respect to second medium. Means at the time you can mark your incident medium and refracted medium clearly. Now, what is the unit of refractive index? Refractive index can be defined as your sin I divided by sin R, that is equal to N or N21 second medium with respect to first medium. So observe, the refractive index is in the form of your ratio form of the same quantity, because I is also your angle and R is also your angle. So refractive index has no unit. In your previous chapter, we have discussed about your linear magnification or simply magnification. Magnification has also your no unit. Now, we know refractive index has also your no unit. Now, we can express refractive index in another ways also. First formula for your refractive index is equal to sin I divided by sin R. Second formula, that is equal to same refractive index is equal to, you can write down sin I. I means your incident ray of light. That means speed of light in first medium or in incident medium. So you can write down refractive index is equal to C by V. Suppose where C is the speed of light in first medium or in air medium, and v. V is also your speed of light in other medium. Speed of light in other medium. Other medium means maybe your glass medium, maybe your water medium, etc. So it is clear. Refractive index has these two formula. Clear? Now, if we interchange the mediums, then what will happen to the refractive index? For example, according to this diagram, this is your first medium and this is your second medium. Suppose I am writing N21 means refractive index of second with respect to first medium. That is equal to speed of light in medium 1 divided by speed of light in medium 2. Now find out your N12. N12 means now we will interchange the mediums. So you can write down what is your N12? Refractive index of first medium with respect to second medium. Means second medium is our incident ray of light through which it travels. So you can write down speed of light in 2 divided by speed of light in 1. Now if we multiply these two, then we can write down here N21 multiply N12 is equal to speed of light in medium 1 divided by speed of light in medium. This speed of light in medium 2 divided by speed of light in medium 1. Speed of light in medium 1. So speed of light in medium 2 and medium 2 cancel. Speed of light in medium 1 and speed of light in medium 1, that will be cancelled. So N21 multiply N21 multiply N12 is equal to 1, or N21 take N12 to the right side, that is equal to N12. What does it mean? N21 or N12 means only the mediums are interchanged. Sometimes in your exam it is written if NAG is equal to suppose 1.141 means refractive index of air medium with respect to glass medium is given to you. Then find NGA means refractive index of glass medium with respect to air. So mark these two mediums of refractive indices. That means only the mediums are interchanged. So how can you find out that is equal to only reciprocal of the 1.141. Then you can solve, and that will be the answer, or that will be the refractive index of glass medium with respect to air medium. Clear? So finally we got three formula for your refractive index. First one is your, according to Snell's law, sin I divided by sin R. Second, that is equal to C by V. C by V means speed of light in air or in vacuum divided by speed of light in other medium. Third formula is your same refractive index, N21 is equal to 1 divided by N12. So this is all about your process of refraction and the refractive index. In the next class, we will find the lateral displacement of glass. With the help of an activity. Thank you.